A 2-mole sample of gas occupies a volume of 11 liters at 298 Kelvin and 5 atmospheres. These values suggest that A. The gas is behaving ideally, B. The gas is not behaving ideally, and the deviation is due to predominance of attractive forces, or C. The gas is not behaving ideally, and the deviation is due to the predominance of repulsive forces. A quick way to figure out the answer to this question is to calculate the compression factor. The value of the compression factor tells us if the gas is behaving ideally and, if not, the reason why it is deviating from ideal behavior. The compression factor, often represented by the letter Z, is simply calculated as PV divided by nRT. In this problem, we are given that the pressure of the gas is 5 atmospheres. The volume is given as 11 liters. The number of moles of gas is given as 2 moles, and the temperature of the gas is given as 298 Kelvin. For the units used here, the value of the ideal gas constant is 0.08206 liter atmosphere per mole per Kelvin. Performing the indicated calculation gives us a Z value of 1.12. Now that we have calculated our compression factor and found it to be equal to 1.12, we can answer the question. First of all, we can eliminate choice A. If the gas were behaving ideally, its compression factor will be equal to 1. Why? Examine the formula for Z. If the gas is behaving ideally, PV would be equal to nRT. The numerator would be equal to the denominator, so Z would be equal to 1. To determine the reason for the deviation from ideal behavior, we compare Z to 1, which is the ideal value. If Z is less than 1, then we say that we're dealing with conditions where the deviation is primarily due to attractions among the molecules. And if Z is larger than 1, the deviation is primarily due to the repulsions. Therefore, since our Z is larger than 1, the correct answer is C. What is the connection between the value of Z and intermolecular forces? To answer this, it is best to rearrange the right-hand side of the formula for Z. If we divide both numerator and denominator by P, we get Z equals V, divided by nRT over P. The denominator, nRT over P, is equal to the ideal volume. In other words, if the gas were ideal, its volume would be equal to nRT over P. Thus, the compression factor is simply equal to the ratio of the actual volume of the gas to its ideal volume. That is why it's called the compression factor. If it's less than 1, it simply means that the gas is occupying less volume than it would be if it were ideal. This happens if the molecules are closer together than they would be in an ideal gas. Molecules staying closer together suggests that there is net attraction among them. Similarly, if the compression factor is larger than 1, It means that the volume of the gas is larger than ideal. This happens if the molecules are farther from each other than they would be in an ideal gas. This happens if there is net repulsion among the molecules.